Hello, this is lesson 3.2, properties of parallel lines. So this is going to be similar to our last lesson where we talked about transversals. However, we justified and we define what a transversal line is. Now we're going to do the same thing, except for instead of just a transversal being a line that cuts through at unique points of two lines, we're going to specify more specifically parallel lines. So let's look at our video notes here. Hold on one second. There we go. So really there's no vocabulary. This is just kind of the standard justify and argument. So we said we're going to look at transversals that cut parallel lines, and they're going to form special angles that give us postulates. And this is why I was saying we need to learn what the angles, the 8 angles formed are called, because they cut parallels, we have postulates to give them special values. All right, so know the postulates. That's really important here. So the first postulate, 3-1, I don't expect you to know 3-1. I just need you to know that they're the same side interior angle postulate. So this postulate said if the transversal cuts two parallel lines, that's important. So we already talked about what the symbol for parallel is. Now when we see lines, and I'm just making up 2 lines here, one thing that's not really specified, so let's call this line P, Q, and R. Okay, so line P, Q, let's just make this S. Line S and R. So line P is our transversal, and it cuts these 2 lines here. Now, they must specifically tell us that lines S and R are parallel, or you're going to see a little symbol like this on the 2 lines. That indicates that lines S and R are parallel. So then you can assume if they don't tell you in this format, if they don't tell you that line S is parallel to line R, or they don't show you these little symbols, you cannot assume and use these postulates to show that they are parallel. All right, so that's really important. Note that on your notes somewhere, because I could give you a problem and ask you for information, and if you don't know or given information they're parallel, you cannot use these postulates to find those. You can't assume. You never assume. All right, so this one's same side says if a transversal cuts 2 parallel lines, then same side interior angles are supplementary. So we already talked about what same side. So 4 and 5 are same side interior, and 3 and 6. So you can say the measure 4 plus measure angle 5 equals 180. The next postulate, and these are all that we already learned, but they're postulates because the transversal cuts parallel lines. Note that. If the lines aren't parallel, these postulates do not exist. Write that down. Postulate 3.1 says alternate interior angles are congruent. So again, the transversal must cut parallel lines. Then the alternate angles are congruent. Note that they said they're congruent, not equal. So what are alternate angles? 4 and 6 and 3 and 5. Then we have corresponding angles theorem. So again, if the transversal cuts parallel lines, then corresponding angles are congruent. So 1 and 5, 4 and 8, 2 and 6, and 3 and 7. We already learned how to identify these angles, but now we're identifying them with the postulates because of parallel lines. 3.3 says is the alternate exterior angle, which says transversal cuts parallel lines and alternate exterior angles are congruent. So 1 and 8, 2 and 8, and 1 and 7. Okay, so let's look at the first problem here. And it says choose any variety of tools such as a compass, protractor. So basically they want you to draw 2 parallel lines and a transversal and label them 1, 2, 3, 4, 5, 6, 7, 8. Then they want you to measure the 8 angles with a compass, which we already learned how to measure, and write what you know about each one and then make conjunctures. So I want you to pause this, try this just for your own sake, but if you do that, we're not going to do this on this video, you'll notice that measure angle 1 equals measure angle 4 equals measure angle 5, which equals the measure of angle 8. Because they're all equal, we can say that those angles are also congruent. Remember, this is definition of congruency, or congruent angles. Then you'll find the same thing, that 2, 3, 6, and 7 are all equal, and you can say they're also congruent. So you can say one conjuncture could be, you can make several, that corresponding angles are congruent. So you could say 1 and 5, right? 1 and 5 are congruent, so they're corresponding angles. You can say same side interior angles are supplementary, because you can see that measure angle 3 plus measure angle 5 will equal 180. So pause this and try this on your own so you can kind of get a feel and understand. It will soak in better. All right, so let's move on to problem 2. So identify supplementary angles. So they tell you the measure of angle 3 is 55. So which angles are supplementary to angle 3, and how do you know? Well, by definition of a straight angle, straight angles measure 180. So if you have a measure of angle A plus a measure of angle 80, B equals 180, then A and B are supplementary, correct? By definition of supplementary angles. They're just giving you the basic definitions. So we know 180 minus 55, because angle 3 is 55, is 125. So any angle X whose measure equals 125 degrees will be supplementary to 3. Now you can come about these, there's 4 angles that are supplementary in this picture here. And you can come about all different ways. When I did it, went through it, I had different reasons. So they say measure of angle 4 is equal to 125 by straight angle, or you could say linear pair. That's what I said, is because 3 and 4 make a linear pair, therefore 4 is supplementary because it's a linear pair with 3, and it equals 125. They said measure angle 8 because the same side interior postulate. So 8 and 3 are supplementary. I said that measure of angle 8 corresponds to measure of angle 4. They are corresponding angles. So that was my definition, my justification. So there's not a right or wrong answer. You've got to use the right postulates and the right theorem. So that's how I got measure 8. 6, they said, because 6 and 8 are vertical angles theorem. So 6, which means they're equal, right? So therefore, it's also 125 because 8 is 125. I happen to say the same thing. And then measure angle 2, they said equals to measure angle 4 because of vertical angle theorem. I said that it's corresponding to 6, which it does. So both of those work. You just have to make sure you have the right justification. So these are the 4 angles that are supplementary to 3. So now let's talk about this proving the alternate interior angles. So they say C and D are parallel. So that's what this little arrow indicates here. And they want us to prove that angle 1 is congruent to angle 7. So we start off with what? The given. All right, so you'll write that in. Then we know, and there's different ways. You got to write your statements, your steps here, and then you can come back and find your reasons. So they went in the route to say measure angle 6 plus measure angle 7 equal 180 because of the linear pair postulate, right? We can assume linear pair. Then they said measure angle 6 plus measure angle 1 equals 180 because of the same side interior angle postulate. Yes, that's true. Then they should have written this, and then 180 equals measure 6 plus measure angle 1. So then you can see the transitive property. But that's really what they did, is from here to here to here, they used the transitive property of equality. So this left side is A is equal to B, and then B is equal to C, therefore A is equal to C. It's the way it's written, it doesn't look like it, but if you rewrote it that way, you could see the transitive property. Then what did they do? They subtracted the measure of angle 6 from both sides because they're the same. It doesn't matter what it is. That's the subtraction property of equality, which gives us measure of angle 7 equals the measure of angle 1, but that's not what they want us to prove. They want us to prove that these two are congruent. And technically, you could use the symmetrical property. Oh, no, we've got it. Yes, to actually write this in the exact correct order. So some books are more technical. I'm not going to be as technical. You would add another step in here and say measure of angle 1 equals the measure of angle 7 by the symmetrical property. And then you can say definition of congruent angles, and you have angle 1 is congruent to angle 7, which is exactly what they asked for. So here, you could either go from here and do one more step and use the symmetrical property, or use the symmetrical property in between. The book didn't. They took some shortcuts, but that's okay. But it just depends on, what tests and your teacher, and I'm not as picky on this particular one. So remember, definition of congruent angles always takes you from equal to congruency or vice versa. All right, let's look at 4. Again, proving angle relations. So we're proving, so given A and B are parallel, prove that 1 and 8 are supplementary angles. So we start with the given, right? A and B are parallel, so that's given. And then we know angle 1 is congruent to angle 5 if lines are so basically it's the corresponding angle postulate. And you could have written that, they go into detail. So if lines are parallel, then corresponding angles are congruent. Or you could just say the postulate, corresponding angles postulate. Then they go from congruency to equal. Again, definition of congruent angles would work here. They say congruent angles have equal measures. Either one will work, but basically you're using the definition of congruent angles. Then they say 5 and 8 are supplementary. Well, angles that form a linear pair are supplementary. So again, the linear pair postulate. Because they're supplementary, we can say definition of supplementary angles that measure of angle 5 plus the measure of angle 8 equals 180. So we've now gone back to the equal signs by using definition of supplementary angles. Then we can say measure of 1 plus the measure of angle 8 equal 180, because what did they do? Up here we said measure angle 1 equals measure angle 5, so we just substitute it in step 5, measure angle 1 plus measure angle 8 equal 180, so we use the substitution property. Then definition of supplementary angles. So because they're equal to 180, measure of angle 1 and measure of angle 8 are supplementary, just by definition of supplementary angles. Okay, so remember, they asked us to show that they're supplementary. They did not say that they're equal to 180. We have to go exactly to what they want us to prove. Now here, find the measure of angle. What are measures of angle 3 and 4? Again, which theorem or postulate justify your answers? There's not an exact way. So these little marks say L and M are parallel and P and Q are parallel. So they use a double to show that these two are parallel and these two are parallel. So when you have these two, you have two transversals. So one way might be to separate them. All right, so if you look at P and M as parallel and Q as a transversal, so let's see, no, L and M. Oops. So we look at L and M. Okay, we're going to assume. Okay, and then we have Q. So this is Q. That makes this 4, 6. They said this is 105 degrees, and this is 7. Well, we know they want us to find angle 4 and 3, so I just separated them. Okay, so these are my parallels, and this is my transversal. Well, I notice that 4 and this angle are same side interior, which makes them supplementary. Therefore, angle 4 must equal to 75 degrees. Okay. Then I need to find angle 3. Well, if I look at, let's see, so P is here, right? So P is parallel to Q, and 3 is right here. Remember, I can only have the 8 angles formed are on one transversal and 2 parallel lines. So I have to break them up to do that. And how can you find, how can you find angle 3? Well, you can say alternate interior angles, right? Measure of angle 3. If you take lines P and Q and transversal M, isn't 3 alternate interior angles with this? So angle 3 is 105 degrees. And we already found 4 because we said same side interior angle postulate. So you have to be able to break them apart like I did, or use different colors so you don't get confused. So here they use P and Q as the parallel lines, and this as the transversal. And you see that they're alternate interior angles. You have to ignore this piece of it. Okay, oops. All right, so let's look at the next one, the last one. So what's the value of y? And this one, again, can be pretty tricky. So what I did is I broke it up. So I've got my line, it's just kind of crooked. And that's my transversal. And these were my parallel lines. So my parallel lines. I know that this is 80 degrees. And if I look at the original drawing, this right here, because of the angle addition postulate, is y plus 40. You've got to be able to break that up. When you look at the original picture, so let's look at it here. If you see, so I drew this line and these 2 parallel lines. I cut this line out, which makes this angle here y plus 40 because of the angle addition postulate. So if I see that this are parallel and this is my transversal, I know that these 2 are same side interior angles, therefore they're supplementary. That's why you got to know what those are. This plus this equals 180. So now I have an equation. Now it's just using algebra. So y plus 120 equals 180. Y equals 60 degrees. And that's all they asked me to find. All right. So therefore, you need to go ahead and stop the video and go ahead and do your problems in your interactive journal. All right. And we'll see you in class.